Welcome to section 5.6 Notes, Inequalities in one triangle. And here's your joke for the day. Which triangles are the coldest? Isosceles. Get it? Okay, so let's begin by talking about the angle-side relationship that exists in a triangle. So in a triangle, the longest side is opposite the largest angle. So the wider the angle, or the larger the angle, the longer its opposite side. What I want you to do on the triangle in your notes is to go ahead and label the vertices. We have A, B, and C. And then I want you to label the sides. AC is 5 units, CB is 12 units, and AB is 13. So by knowing the length of each side, I now know which angle is the largest. So let's start by labeling the sides from least to greatest. So we have one side that measures 5. That would be side AC. So it's the smallest. The next side, CB, measures 12. And the longest side is going to be AB. Okay, so there's our sides from least to greatest. If we know the sides, we can use that to find the angles in, or not find the angles, but to label the angles. So the angle that's opposite of side AC, here's side AC, that would be angle B. So angle B is the smallest angle. The angle that's opposite of side CB is angle A. And then your largest angle is going to be opposite of side AB, which is angle C. There's another relationship that exists in a triangle as well, and this deals with triangle inequalities. In a triangle, the sum of the lengths of any two sides must be greater than the length of the third side. So start by labeling this triangle. We have X, Y, and Z. Okay? And I'm just going to label side XY as side 1. This one can be side 2. And XZ as side 3. Now 1, 2, and 3 do not represent the lengths, but just represent the sides. If I add sides 1 and 2 together, that sum needs to be greater than side 3. And this has to work for any combination that I pick. So let's say we add side 2 and side 3. That sum needs to be greater than the first side. And you have one more inequality that you would need to check, and that would be side 1 and side 3, whose sum needs to be greater than side 2. So you have to check that this inequality, or that this relationship works for all three inequalities. Okay, let's start by practicing those two properties. So the first practice problem that we're going to work on, we have number 1. We want to write the angle and the side measures in order from least to greatest. Well, I notice in this problem that I'm only given side lengths. So my smallest side length is 17.2. That means side or segment GH is the smallest side. Then 19.6 comes next, so that would be segment GF. And the largest length we have is 20.4. So that is going to go with segment FH. So I have my sides listed from least to greatest, and now I can use that to name my angles. The angle that's opposite of GH is going to be angle F. And the angle that's opposite of side GF is angle H. And since side or segment FH is your longest side, then angle G is going to be your largest angle. Let's try this with another example. Notice in this example we're not giving any side lengths, and in fact we're not given all three angles. But we do know enough information that we can find our third angle, angle R, the measure of angle R. You have to use a triangle sum theorem. All right, so what is the missing measure of our angle? Well, hopefully you're all saying it's 48 degrees, because 72 plus 60 plus 48 needs to equal 180 degrees. All right, so now that I have all three angles, I can use that to list my angles from sides, or from least to greatest. And so let's start there. Well, my smallest angle measures 48 degrees, so angle R is going to be my smallest angle. And then we have angle P is my next. And finally, angle Q. Well, once I know the order of my angles, I can use that to find the order of my sides. So the side that's opposite of angle R is going to be segment QP. And the side that's opposite of angle P is QR. Alright, so if 72 degrees is my largest angle, its opposite side is in PR. So I have segment PR. Okay, what I want you to do is finish number 3 from your notes. And I will check it next class time. Okay, now let's move to a few different practice problems. What we're going to do here is we're going to state whether it is possible or not to form a triangle with the given lengths. So example 4, I have one triangle that measures 2 centimeters, 2 centimeters, and then 5 centimeters. Well, if you remember, the property said that if I add up any two sides, the sum has to be greater than the third side. So as soon as this does not work for one sum, it's not going to form a triangle. I don't have to do it all 3 times. So let's just take the order. 2 plus 2. Is that greater than 5? Obviously not. It equals 4. 4 is not larger than 5, so right away I can stop. If I have sides with, or a triangle with these side lengths, it will not form a triangle. So this is not possible. Let's try example 5. Here I have side lengths of 4 centimeters, 2 centimeters, and 6 centimeters. Well, let's check this to see if it holds. So I'm just going to add up my first 2 sides together. 4 plus 2 equals 6. However, the sum, 6, is not greater than the third length. They're equal, and it must be larger than. So again, this triangle is also not possible. Okay, what I want you to do again is to finish number 6 on your notes. So you have 2 problems. Finish number 3 and finish number 6, and I will check them. Also, if you have any questions, write them down and save them for class.